Good evening, everybody. As you can see, I've tweaked my theme a little bit. Now with 60% more purple and 90% more space. Because both of those things are cool. The only downside is this particular VRM tends to blend in a little bit. Alright. Today's Universe Sandbox challenge is to take two of my favorite sciences and mash them in a way that means we're not doing either of them quite correctly. And by that I mean, I am going to be using, roughly, sort of kinda, the Niels Bohr atom model to make solar systems. Or at least trying. Because like I said, if you're combining them in this way, neither of them are being done correctly. But that's fine. I'm also enjoying the crisp black cherry sparkling water. Brand unspecified. Okay. First up is going to be an easy boy. If I can find a tab. Let me find a tab. Yes, I am aware that hydrogen is the lightest and most abundant element in the universe. Thank you. Oh. It glows purple in plasma. Eek! Eek! Ooh. Some of these numbers, I'm not quite sure what they mean, but that's fine. Interesting. Okay. Tom. My sound alert? Let's see. So, we're gonna struggle to remember where to put my chat box because ba-doop boop ba-doop boop boop. Let's start with a random main sequence star. Now here's where things get funky. Hydrogen. Now, I'm going to let the radius calculate automatically. But the mass, what I'm doing is I'm taking the standard atomic weight and dividing it by 10 and then using that number as solar masses. So it looks like it is 0.1008, give or take. Okay. Oh, it's just bigger than Jupiter. Interesting. Okay. As for temperature, I haven't figured out what to do with that yet. Oh, my Discord alert? Yeah, because I forgot to set something. Because it was supposed to be a D&D night, and then we didn't do D&D. Let's see. Okay. Melting point of hydrogen is only 13.99 Kelvin. The boiling point is only 20.271 Kelvin. Hydrogen wants to be a gas. Very much. Okay. I'm just going to be weird about it and not science that too hard. What I'm going to do with the temperature is I'm going to do the, is the, I can never remember if period is the verticals. Rows. Column. Okay. I'm going to do it by group. Oh. Let's see if hydrogen survives. That is a very red star. I don't even know if that's going to be luminous. Hmm. It appears to be staying a star. A very weak star. Okay, maybe we'll... No, we don't want 10,000. Let's do it twice the group number, because I'm worried for hydrogen's existence if we do that. I just let it pick a random composition and it looks like it's oops all hydrogen hours, which is appropriate. Okay. Now for the fun part. Since our hydrogen sun is fairly stable, we need our electron. I'm just using the star as the nucleus. I'm not worried about trying to make neutrons and protons and blah, 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 blah. I'm just using the star itself as the nucleus. Yeah, our little hydrogen sun is puttering along just fine. So, the problem with the Niels Bohr model, trying to figure out the ratio of electrons sizes, is that they're just kind of a vague dot of ugh, and the current more correct model recognizes that there aren't really orbits as such. It's just kind of a blobby cloud of negatively charged subatomic particles. So I'm just going to be going back to the Niels Bohr model, hence the pun title of the stream, and what I learned in high school. It's going to be trickier once we get up to the higher elements with the valence electron shells, because all I can remember is how the first two work, but Ooh, pardon me. So, I'm going to be using a random moon, randomly generated moon, as our electron, because they are so small. And I'm going to be putting it at a quarter of an AU. Yeah, we are set to orbit. Do 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 do. Because this particular avatar was inspired by the Children of Eternity from Marvel, specifically Now and Then from Loki, the God Who Fell to Earth, because that's one of my favorite comic runs ever. But just eternity in general. And because I figured out how to do that to make the eyes glow. Hee. Okay. Electron. Electron 1. I don't believe this is going to be the least bit habitable. But... oh, please. Dr. Strange will suffice. So we have a little electron. 2.5, please. Oops, did I increase the eccentricity when I did that? I think I did. Eccentricity 0, please. There we go. We've got our little hydrogen. Little one single orbiting. I believe that's technically a red dwarf. It's just orange. Hydrogen. Done. Ish. Let's see. How long does it take the electron to go around? Oh, 4.7 days is a year on hydrogen's electron. That's fast. But I guess that makes sense. Because eyes in the dark, one moon circles. In this case, one planet. But yes, one moon. Hydrogen is a fairly simple one. In fact, it is the simple one. The first atom known to have existed. It is the lightest and most abundant chemical element in the universe, constituting about 75% of all normal matter. That was mildly anticlimactic to make our little hydrogen. Oh, hey, the average temperature. Actually, I'm curious about something. Nope, let's focus in on electron 1. Ooh, to do. Oh, it's just iron silicate, but. Boop-a-doop-a-doo. What am I looking for? Where is the tab? Huh. Fascinating. Life likelihood is 0%, but that's because there's no water or atmosphere. You know what? Just to be fun, let's give it an atmosphere. If I can figure out how. Is there a simple atmosphere button, please? Aha. Let's give it a Martian. Pressure and composition. Martian atmosphere. Surface. Settle liquid. Equalize gas. Visuals. Let's do vegetation if it gets there. There's nothing fun on this surface, but that's okay. Oh, let's rename it hydrogen 1. So we can throw it into our planetary nonsense. Okay. Let's do Earth, but replace pressure and comp. Okay. Okay. Still probably won't have any life, but that's fine. Set a liquid, equalize gas. No. Stabilize phases. Well, here's our little hydrogen 1. Let's... Oh yeah, that replace pressure thing. Yeah, that maintain pressure button? That's working for us. Oh, we got a life likelihood. It's going down, but we got one. There's also a big tornado. And by tornado, I mean hurricane. Because those are totally the same phenomenon. I do chemistry and astronomy, not meteorology. Okay, that is our hydrogen system. Save. Hydrogen system. Save. And just for funsies, save hydrogen the star. And hydrogen 1. Oh, look! It's got a vague greenness to it. Interesting. All I did was change the atmosphere. Stateless phases? Yeah. Hydrogen 1. Now. Boop. We step up a bit. Random main sequence star. Doesn't matter. Helium. Okay. We are looking for solar masses, please. Which is going to be 4. Nope. 0.4. Oh. 3. It is actually a very stable atom. Which I'm not surprised because it's a noble gas. So it's group 18. So I was doing 2000 times group number. Why did I make myself do math? Our noble gases are gonna be spicy! Which is ironic, considering. You know, I probably should have done it the other way around. Oh well. So we've got our helium here, our helium star. That's a pretty color. Oh, that measures surface temperature, not core temperature. Okay. Ooh! That's a bright star. That's fine. Okay. Now it's time to add us some planets, which are going to get absolutely roasted to oblivion. Because they are both going to be in the innermost shell. Random moon. Let's see. I'm just going to do this. Helium 1. We want it at A. No eccentricity, please. 0.25. I put it in the wrong spot. And, oh, yep. Helium 2. I missed by a couple of decimal places where I was putting it. There we go. We got 2 planets along the same orbit of helium. Where is helium's habitable area? Just out of curiosity. It's not gonna be this close. Not with that temperature, I'll tell you that much. But hey, view. It's the view tab. Habitable zone. Okay. Yeah, the habitable zone of helium is way far out. So the noble gases, your inner planets, are gonna get cooked. Let's see how long it takes them to set on fire, basically. Orbital period is 2.35 months. I think I may have put hydrogens too close. It's fine. I speed things up a little. Yep. Yep. They're gonna catch on fire. Where's the rotational period? Rotational period, where are you? Oh, it's got a decent rotational period. It's just getting cooked like a rotisserie planet. It's a rotisserie planet, but it's helium. Yeah, because blue stars are way hotter. So I'm doing temperature that way. It's extremely toasty. How long before the planets actually start melting? That's what I want to know. Hey, did you get more eccentricity since I last talked to you? Don't do that. What about you? Did you get... Yeah. There. There's our little helium system. Whee! Oh, why is helium-1 falling into the star? It's not. Okay, it's just catching up to where I corrected its orbit. Okay. Guys, let's look at the Earth likelihood. Life likelihood. Let me guess, nothing. Earth similarity is 14.6%, but, you're still gonna die. Yeah, the coldest it gets is over 500 degrees Celsius. Oh boy. You are not having a great day. Ah, save. Helium system. Then I'm going to save the helium star. Doop. A colorless, odorless, non-toxic, inert monatomic gas, and the first in the noble gas group in the periodic table. Its boiling point is the lowest among all the elements, and it does not have a melting point at standard pressures. In other words, this thing doesn't even turn into a solid unless things are getting real weird. Oh, the boiling point is only 4.22 Kelvin. Yikes. Huh. On Earth, it is relatively rare, 5.2 parts per million by volume in the atmosphere. Most terrestrial helium present today is created by the natural radioactive decay of heavy radioactive elements, usually thorium and uranium, as the alpha particles emitted by such decays consist of helium-4 nuclei. Interesting. New. Boop. Main sequence star. It's time for Lithia. Not the medication, although... Eh? Lithium comes from the ancient Greek word lithos, meaning stone. They were really creative. Standard appearance is silvery white. Standard atomic weight 0.6938-ish. Boop. And its surface temperature was 2 times the group, so that's another ready orange one. Let's find a fun fact about lithium. Lithium has the lowest density of all metals under standard conditions. It can float on the lightest hydrocarbon oils and is one of only 3 metals that can float on water. Intriguing. It was first discovered in 1817. Oogie. It's planet time. Random small moon, a random moon. Before I hit it in motion, I'm gonna, oops. Dupe, dupe, and then dupe. These are all at the wrong spaces right now, so major axis needs to be 0.5 AU. Yeah. And these are 0.25 AU. Okay. And lithium 3. Let's see, what is our average surface temperature? Oh, lithium 3 is not bad at surface temperature. Where's our habitable zone on lithium? Habitable. Oh, lithium 3 is right in the habitable zone. Okay. Lithiums 1 and 2 are a little spicy, but I'm gonna add them some Earth atmosphere anyway. Pressure and comp. Pressure and comp. Pressure and comp. Let's go to lithium 1. Oh, that's interesting. Let's do some settle liquid, please. Equalize gas, please. It's an interesting planet. Okay. Where's lithium 2? Doop, 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 doop. Settle liquid. Equalize gas. I guess I should stabilize temperature. Nope. Stabilize phases. That's what I wanted. Interesting. Let's go back to lithium 1 and stabilize your phases, because I clicked the wrong button. Stabilize phases. There we go. Some shallower water, but we got water. Let's see. Do we have a life likelihood? It's a little toasty, but oh yeah, not bad, not bad. Not great, but not bad. Oh, we got ourselves a nasty hurricane. Oh, visuals. Let's do vegetation visuals, please. What? Is that a circular vegetation pocket? It's hard to tell in this orange of a sun. Where's lithium 2 now? Because we need to turn on the veg. Okay. Boop. Oh, those are... that's a Coriolis effect. Oh my goodness. What is all that happening up there at the pole, and why is there a sharp line? That's vegetation? Weirdest forest I've ever seen. You know what, let's turn on city lights, because why not? Habitability. Interesting result. Lithium 1, let's turn on your city lights. Lithium 3. Now, you are a different matter. Let's actually, yeah, turn on your city lights, turn on your vegetation, head to the composition, and stabilize phases. No. Set a liquid. Equalize gas, equalize gas. That was the button. Stabilize phases. According to this, it's actually... I wouldn't call them habitable with less than a 0.1% chance, or with about a 0.1% chance, but it's getting some interesting results. Partly because I'm giving them a little bit of Earth atmosphere, so not in amounts, but in pressure. Yeah, lithium 3 is a little on the cold side, but is there a freeze button? Freeze all, melt all, vaporize all, stabilize phases. Maybe that'll help. It's kind of hard to see exactly what's going on because the sun is so darn red. What's the atmosphere color? Visuals. Atmosphere simulated, okay. Clouds realistic. Yeah. Heat glow, simulated snow, ice, liquid, city lights, vegetation, elevation. Okay. So I don't think any of them are outright habitable, but some of them are turning out very interesting. Let me just go back to lithium 1 here. Boop. Yeah, there's only about a 0.1% chance of life, which is, statistically speaking, not terrible. Oh, that's a lot of clouds on lithium 1. Okay, what the heck is happening here? Because I don't think that's an elevation related thing. Okay. Freeze, melt, vaporize. No, melt. Equalize gas, settle liquid, stabilize temperature? It's still a bit on the extreme side, but at least the shapes make more sense. Stabilize phases. There we go. Yeah, you wouldn't want to try to live on lithium 1. Those winds are nonsense. Sorry, what was that line happening? Oh, that's an orbit line. Why are you bouncing in and out of your orbit line? And what is this happening? I could go into the terraforming menu, but we've got a lot of elements to do. Because honestly, what the heck is this? It's pockets of vegetation, but they don't make any sense. Okie dokie. We got some boss storms happening, though. It must be spinning really, really fast. How fast is it? How long is its day? Rotational period, half a day. Okay, that's not horrible, I guess. Okay. We can save lithium 1. Lithium 2. We can save. Lithium 3 we can save. It's an interesting planet. I'm gonna have a planetary battle royale once we finish a series. Hey. Maybe even a stellar battle royale. Did I save the lithium star? I do not have any idea. I don't remember. Since you can't put those in... No, I did not yet. Okay. Lithium star. because of its relative nuclear instability, lithium is less common in the solar system than 28 of the first 34 chemical elements, even though its nuclei are very light. The transmutation of lithium atoms to helium in 1932 was the first fully human-made nuclear reaction. Interesting. Okay. Pause it, please. Stars, random main sequence. Wow. Beryllium. Beryllium. Mass. We're getting close to stellar masses now. 0.9012-ish. It's group 2. So that's going to be not 4 kelvins, 4,000 kelvins. My brain saw the K and thought it stood for 1,000 and not Kelvin. What do you mean? Are you protesting my physics experiments? Miles looked at me like from the bookshelf like, am I supposed to be here? Okay. Melting point of beryllium is 1,560 Kelvin. Boiling point is 2742 Kelvin. Among all metals, beryllium dissipates the most heat per weight unit, or per unit weight, with both high specific heat and thermal conductivity. Interesting. We've got a nice little yellow star here. Is hot. Oh, we can stand on it. That's not a good idea. I like my feet. Okay. Now time for our planets. Shishmar moon. So we have 2 at the 0.25 range and 2 at the 0.5 range. Ish. Beryllium 1. Beryllium 2. Oh, looks like some of them are coming with water. Interesting. Marked as dwarf planets. Planets. Okay. Zoom in on beryllium 1. Oh, let's not have that super choppy. Life likelihood is at 3% just off the bat. That's interesting. Stabilize phases. No? Okay. Settle liquid. That's still choppy. Freeze everything. Melt everything. Vaporize everything. Settle liquid. Stabilize temperature. Settle liquid. Equalize gas. Oh, okay. Stabilize phases. Oh, what? No, we don't want another weird ring situation. What is this? Okay. Okay. 0.25 AU. Okay. Okay. Oh, that's weird. Is that a big gas cloud in the middle? Let's turn on veg and city lights. Okay. Ah! I don't know how to make it not do the weird... Okay, I guess we just let it run its course for a bit. And it'll gradually stop doing this weird cue ball thing. I say cue ball, not cue ball. Various other billiard balls. I can only assume that that's a cloud layer in the middle. So while that goes, weirdly, let's move on over to beryllium 2. Which currently is rock only, but I'm gonna add it earth, pressure, and composition, atmosphere. We've got some intense geographical features here. Settle liquid. Melt all. Freeze all. Melt all. Vaporize. Stabilize. Huh, yeah. 0.06% chance of life. Let's actually see. 0.25 AU, because we need them exactly on the same. Yeah. Like that. Now we watch as that does its boogie for a little bit. Oh, vegetation suddenly turned on. Okay. The vegetation threshold is really weird because clearly that is not going to be all supporting veg. But the temperature's not bad. Okay, so I'm going to leave that and swoop on over to beryllium 3, which also comes preloaded with some atmosphere and even some water, which is very nice of it, and a 3% chance of life, as we know it. Stabilize phases. Settle liquid. No? Stabilize temp. Oh, okay. Stabilize phases. Maybe if I click melt all and then settle the liquid, then stabilize phases. There we go. Veg and lights. Oh, right. Motion. Should be 0.5. 0.5. 0.5. Thank you. We need no eccentricity. Oh, what is this shockwave headed towards the equator? Oh, this is on the wrong playlist. There we go. I don't like that it has rocky poles, because that doesn't make a whole lot of sense, but whatever. Oh, we got some... Is that an ice formation just randomly? No. Okay, sometimes this game does weird things. Do. Brilliant 4! That's kind of an oblong planet. Interesting. Okay. Weird decision to give it that, but... Pressure and comp. Visuals, veg and lights. Not necessarily in that order. Melt all. Set to liquid. There we go. Stabilize phases. Set to liquid again. That is a blobby boy. That's so weird. Motion. 5. 5. It is at this point that I realize how silly this particular project is, but that's fine. It's a flat, weird planet. It's kind of bulgy. But that's cool. What's our 0.5% chance of life? If I knew how to make it bulgy on purpose, I would be playing with that a lot more. Looks like we got some plants, some archipelagos. There we go. Let it spin a little more. Doot. Make small thing big. Is it just me or is that orbit getting smaller? No, it's just me. Oh! I didn't mean to click on the button. Okay, now let's check in to see if this weird situation has resolved itself. Oh! You right. Okay, well, the weird striations pool ball, billiards ball situation hasn't fixed itself, so that's fine. But first we see the sun. Save. Save. I'm gonna have so many random planets when I'm done with this. Actually, I'm gonna be so many planets right by the time I get to, what is that? Neon? Beryllium 3. I still don't like your weird choppy poles. And your weird central ocean. Nice. But it's fine. Do. And our weirdly oblong beryllium 4. I don't understand how it got to be so oblong, but that's fine. Oh, it's going fast, that's why. Gosh, how long is its day? Oh, my gosh. 0.789 of a day. 0.0789 of a day. That's why it's oblong. Jeezy. See how long that is. 24 times 0.0789. Yeah, that thing spins and does a complete day just under 2 hours. No wonder it's all squishy. That'll do it. Yup. That was my pinky. No, don't replace beryllium-4. Cancel. Wow. Did they finally add that to the game? Yeah, you don't want to try to live on beryllium-4. That is a flat planet. Apparently the poles are decent, though. Yup. Oh my gosh, this is the squishiest planet I've ever seen in this game. That is awesome. I don't know if they actually added that or if that's a new thing. Now I'm kind of tempted to play around to see if I can actually squish planets or if that's just special to that one. Lithium system. If I could spell system, that would be good. Nope. You're right, beryllium, not lithium. Wow. That is a squished planet. Okay, who's next? Boron. B-b-b-b. Okay. La 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 la. Okay. Ooh, come on. Random main sequence star, please. Oop. 806. Masses of the sun? Boron is synthesized entirely by cosmic ray spallation and supernovas, and not by stellar nucleosynthesis. What are you doing? Really? Are you sure? Are you still mad at me because I forced you into the kitty tunnel earlier? Meow. Hi. Hi. That's a good boy. Since Miles likes to go out onto the deck and flop and roll, I say deck, it's a patio, and roll back and forth and back and forth, I bought them a little cat hutch thing with a tunnel in it that's enclosed, so I don't have to worry about them jumping up onto the railing. Miles is cautiously optimistic. Julian freaked out. Didn't you? Yes, you did. You freaked out. You jumped so big you turned the whole thing over twice. Yes, you did. I didn't think a little kitty could do that much. She's looking at me like, I'm cute. And he is. Temperature is group 13. So, temperature 13 times 2000. Yeah. That doesn't seem right. Yes, it does. It's fine. Composition. What do you know? There's a 0.096 life likelihood or Earth similarity on a star? Concerns. Oh, that's a fun thing to start to mess around with. Okay. Huh. I don't know what many of these words mean, but that's okay. Boo. Melting point is 2349 Kelvin. Boiling point is 4200 Kelvin. Ish. Actually, not ish, which is weird. It's time to toast some more planets. Random moon. So we need one at 0.25 ish. Actually, then we need 0.5. We need 3 of these guys, so ish. I don't know how to make an equilateral triangle like this, but I tried. Ah. Well, that's a name. There we go. I find myself unable to type. Okay. Let's refine their distances now. Should be 0.5, 0.5. Okay. Five, 5. I have 2 boron 4s. I apparently cannot count sequentially. 5. Okay. 0.25. No eccentricity, please. Just to make things stable. Oh, 2.5. Ah! 2.5, please. Thank you. Point 0.25. Okay. Now we swoop on down to boron 1. Yeah, that thing is getting roasted to absolute smithereens. But I'm going to give it an atmosphere anyway because I don't know. Settle liquid. It's going to get vaporized, but it's there. This is also in the wrong playlist. This to be my high tempo playlist. No, please hold. Nope. I know that's the one we just heard. There. Okay. Okay. Boop, boop, boop. Ah, yes. Oh, we just did boron 1. What am I thinking? We need boron 2. The name for boron comes from borax, which was used as a glaze. In China in around 300 AD. It was another fast spinner. I could tell. It's oblong. Okay. Composition. Pressure and comp. Set a liquid, please. Oh, yep, it's flinging its atmosphere. Ha ha ha. That thing is moving too fast. How fast is that going? Oh, 0.2 of a day. That's better. That's like 4 hours. That's still really fast. Okay. Is boron 1 flinging its atmosphere too? No? Okay. Boron 3, which came with water. So I'm not even going to mess with the atmosphere there. Visuals, veg, city light. So 1.34% chance of life. That's not happening. Really? Surface. Settle liquid. It's a very wet little planet. Boron 4. Also a squishy boy. Who's probably going to throw the atmosphere away like a toddler being asked to wear a shirt. Yes. It's not too bad. This is a weird circular phenomena. But that's fine. Oh, we do have vegetation. Let's see. 0.374 chance of life. That's a squishy boy. Where's boron 5? Nope, we want 5. Which also already comes with its own atmosphere and very squished self with a 5% chance of life. Interesting. I'm so excited for Comic Palooza. I'm gonna do a show and tell when I get back. I thought that said set the phasers of the materials. Too much stow. Okay. Now we push a play. This is not a place you'd want to live either. How fast is its day? Yeah. Around 2 hours. 2 hours of a day will squash your planet. Let's pop on in on boron 1 for a little bit, which is throwing its atmosphere away. It says, no, I don't wanna. Yeah, because it's way too close to the sun. Oh, it's really not. What? I'm confused. That should be way too close to the sun. Either way, boron 1 is leaving a trail. Boron 2, stabilized temp, is definitely throwing away its atmosphere. Okay, where's 3? 3, stabilized temp. It's a little warm. Why are you getting these weird bands? I don't like it. Don't know what that is. Well, the poles are starting to freeze over, so... At least the South Pole is. Oh yeah, the poles are starting to freeze over a little. There we go. Boron 4. Stabilized temp. Yeah, you don't want to live here. What is with these weird bands? I don't understand it. Okay. Boron 5. Stabilized temp. Is hot? That doesn't make sense. I mean, I guess it's spinning really, really fast, so... I don't think it knows how to stabilize the temperature correctly. Because why is the north part on fire? But also closing it around with ice. I think that's ice. That's either ice or cloud. I don't know what's happening. Equalize gas. Set a liquid. Okay, let's bring the temp down. until he averages right around 0, and we'll see how it stabilizes from there. Because this planet doesn't make any sense. Turn off the clouds. Okay. Why do you have stripes? I don't understand. And how is your North Pole frozen only around the edges? You're not making any sense, Universe Sandbox. I say as if I'm not trying to do something that inherently makes no sense to do. Okay. Speed it up a little. Okay, that's better. Ah, still too fast. Okay. That's much better. Okay, let's go back. You've lost your motion again. That's fine. 0.5 AU, please. Have you been holding up? Okay. You seem to be okay. You're spinning really fast, but you seem to be okay. Okay, how's Boron 3 holding up? With its weird cloud situation. Oh, that's not cloud? What the heck is it then? Is it ice? I can't believe that to be ice. Oh, it's just a thick atmosphere. Okay, why does it have such a thick atmosphere? I do not know. But it came with it, so... You can get away from it at the poles. The South Pole, for some reason. It's a very blue planet. Gaseous. Oh, the inner borons are losing their orbit now. Are they? Oh yeah, this one is. Yeah. Okay, Boron 1, how have you been, buddy? Not the star. Boron 1, please. Besides leaving a bunch of garbage out. Whoop. Yeah, Boron 1 doesn't want to have an atmosphere. It just doesn't. Yeah, it's a little on the spicy side. Yeah, when its liquid depth is measured in millimeters, that's what it's getting rid of. Okay, Boron 1 does not want to keep on its anything. Boron 2. Also ejecting atmosphere. Because it's spicy. And its liquid is all weird. Okay. So this is our boron system. Let me let it run a little longer. All nicely spinning. Honestly, I'm a little bit bored now, so I am going to say the boron system. Oh yeah. So what I'm going to do is I'm going to save these, and then I'm going to battle royale some stuff. Okay. Okay. Did I save the star itself? I don't remember. I did not. Okay. Save. Yeah, sometimes I start with a star, sometimes I don't. So trying to remember what I have and have not done is just not a thing. So, now we are phase changing, because I'm slightly bored of the chemistry stuff. Too predictable, so now I'm gonna throw stuff at stuff. Starting with all my elemental stars. Let's put, nope, not Earth. Boron goes there. Helium, this will also get you an idea of relative size, I guess. Actually, yeah, let's line them up. Let's line them up. Not that these atomic radii are actually correct, but they're relative to... They're auto-generated by mass. So there's hydrogen, there's helium, there's lithium, there's beryllium. There it is. Beryllium. And then boron. The colors in this case do not mean a darn thing. So, let's let gravity happen. Oh. What? How did helium win? Did I click launch on helium instead of still? Eh? I do not have any idea what just happened. Okay, let's try that again. Hydrogen. Why is it drawing a line to over here somewhere? I don't know, and it doesn't really matter. Okay. Hydrogen. Helium. Lithium. Beryllium. Not the planet. Beryllium. Boron. I'm gonna run that a little slower because I have no idea what the heck happened, but we're gonna focus on lithium. Okay, that makes sense. Hydrogen just got left behind. Okay. Come on, buddy. Oh, that's interesting. It's a blobby star. How did helium survive? Here, I'm gonna stop it moving. So that maybe it can pick up hydrogen. This is on the wrong playlist. Forgive the live playlist edits. There's no better time to do it, really, than when you're playing. I don't understand how helium lived and everyone else died, but okay. This is interesting. Okay, it's not picking up hydrogen very well. Halt motion. There we go. Oh! What? We got a disc! We got a wacky star disc! I guess they did add that in the latest updates. What is its temperature here? I was not expecting... Well, there's like no game sounds, so... Oh! Thank you for telling me I was silly and forgot to turn my music back up. Sometimes I forget to do that. But the game doesn't really have any sounds, so... At least you didn't miss that. And at least I haven't been talking and nobody's heard me this whole time. I just had my desktop audio source turned all the way down because I faded out when I end the stream, and usually I put it right back up to where it was after the stream's over. I just forgot. So thank you for telling me. There's always some kind of technical difficulty or it wouldn't be a me stream, I guess. Yeah. That's okay, last time I did Universe Sandbox I had the same issue. I forgot to turn the volume back up. So there was nothing the entire stream because there was no audience to tell me. Because when I go in the living room, my TV auto levels the volumes so it turns the music down for some reason. But yes, we got a star disk. What's our temperature? Average temperature, 70, really hot. Yes, it is appreciated. Let's rename it to Star Disk. Whoa. They did add oscillation and gravitational spinny stretching. I forgot the actual word. That's so cool. Just got a random blob now. And a big old supernova remnant. Huh. The game must get very confused. Kablooey 1. Can I save Kablooey 1? Oh, it named it all Kablooey 1. That's not what I wanted to do. Or is it? Fragment, explode, land, add rings. Well, we got a random supernova out of it. Oh, that's a pretty one. No, I don't want that one. I want the... Oh, it doesn't matter. I'll just save it. Kablooey 1. It's a Type 1A supernova. Does this game even have any others? I'm curious. What if I take the entire Kablooey supernova, convert fragment to full body? Oh, it's not doing it on all of them. Okay, fine. New. Let's look in my objects. Where's Kablooey? Did it not save Kablooey? It didn't save Kablooey. That's fine. Okay, are these actually orbiting? Because that's annoying. It says flying into, that's fine. Flying by, flying into, okay. If they're flying into, then that means it'll eventually become a thing. Eventually. Oh, it didn't make a moon. I was like, did it form a moon? But that's just a dark cloud. Flying by. It's just a cloud. Okay. So here's what I'm gonna do. I'm gonna do that. And this should help. It's flying by. I'm not gonna bother if it doesn't have anything, or if it's... Aha! See, that one turned into a moon. Like, into... orbiting. Okay. Into flying by. If it says flying by, I'll leave it be. What was that made of? A lot of things. Flying by. Flying by. Flying into. Okay. Flying into. Flying into. Flying into. Flying by. Just cloud. Okay. By. It's just a rogue object. Okay. Oh. Okay. So some of those moons crashed. Flying into... Completely got rid of our moons though, unfortunately. That got real hot real fast. Oh, And it exploded. Okay. It exploded. And there's not really an undo, so here's what we're gonna do now. Solar system. Although I do wish there was a super basic version of the solar system, because my goodness. Let's see what happens. I'm gonna pick a random asteroid here. What is your distance from the sun? I want you to show me what the distance from the sun is. Oh, lateness factor. Okay, fine. I'll put it in the same orbit as Ceres then. Fine, be that way. Distance 2.58 AU. Let's see what happens if we put Jupiter in the wrong spot. Rare. And where's the eccentricity button? Oh, that is too many. No, please. Let's put Jupiter in the asteroid belt. Okay. Jupiter, what are you doing? You're leaving forever. Okay. Auto orbit, please. Okay. Jupiter, you're supposed to be a vacuum cleaner. Let's do this to keep an eye on the impacts. Jupiter's the great vacuum cleaner of the solar system. It's gonna go faster. Is anything hitting it at all? Is it affecting anything at all? It better be affecting. It'd be like a pointless collide with others. Okay, yeah, pull others. It is. Is it gonna eat Ceres? Not quite. Oh, it's definitely sending Ceres off orbit though. Also, Pallas. Jupiter's the tank. Protecting the planets of the inner solar system. Okay, Jupiter is not slurping things up as much as I'd like, so let's make it bigger! 2 Jupiter sized. I keep thinking that's another planet, but it's not. Not Doris, I mean that little nebula back there. Which is just part of the background. Yeah, the asteroid belt is getting all confused, but it's still fundamentally the asteroid belt. Even at double size. Let's make Jupiter even bigger! 20 size Jupiter. Yeah, now Vesta is showing some issues. We got some asteroids that are like, I don't know what to do, boss. Here comes Pallas back. Are we actually trapping the asteroids, or are they just getting Voyager 1'd? I think it was Voyager 1. It was one of the Voyager probes. I used Jupiter as a big ol' slingshot. Some of these asteroids are definitely doing that. With our 20 Jupiter. Oh yeah, now we're getting some effects. It hasn't really bothered the inner planets yet, except for Pallas being all whack. And the sun. Don't know what the sun thinks it's doing. The sun just straight up is not having a good time. Pallas is straight up not having a good time. Let's make Jupiter even bigger. 200 times. Oh. Now it's a non-ignited star. I mean, it's a star, but it's a brown dwarf now. Oh, it's core temperature. Ah. Stabilize phases. Actually, let's hit the stabilize temperature button if I can. Oh, 10% luminosity increase. Yeah, now things are getting real messed up. And we are all dead. It doesn't know which star to orbit, and... no, we're not quite dead after a year, somehow. But we are not having a great time. Temperatures have plummeted. I'm gonna focus on Earth's stats, but have us orbiting Jupiter. Yeah, we are not having a good day. Oh, passed off to the sun. We're warming back up. Oh, we got way too close to the sun there. Mercury's still just vibing, and Venus. Whoa, that was a weird... oh dear. Oh no! Okay, let's slow this down. So you can focus on Earth for a little bit. Stabilize temp. How close do we get to this? Or how far do we get? Where's our apogee stuff? Motion. Oh. We get slightly beyond Earth's distance. And also way too freaking close. Okay, that's too slow. Don't need it in hours per second, I guess. We're heating up, we're heating up, we're heating up. That is stupidly close to the sun. How's that in kilometers? Yeah, only a few million kilometers? Yeah, you roasty. Where did our Jupiter go? There's our Jupiter. Still doesn't really have any luminance. Let's fix this until we can see just a little glow. Okay. It was not calculating, it's just showing it as black. Let's make it hotter. There we go. There's a little Jupiter star. Still causing havoc. Let's make it even bigger. Mass. Oh, now it's twice the size of Jupiter. Twice the mass of Jupiter. And those little asteroids are heating up. Why is my surface temperature doing nothing? That's a blobby red dwarf. Looks like a pizza pocket. I'm going to name it Jupiter. And then save it. Because I think that's funny. Let's cause some nonsense in the solar system, because now it's bigger than the sun. Yeah, nobody knows what's going on anymore. Except trans-Newtonian objects, they don't seem to care. Maybe Saturn. Where's Saturn? Where's Saturn? Oh, it does. Where's Saturn? Oh, Saturn. Yes, Saturn's all screwy. Yeah, Uranus is all screwed up. Neptune is almost fine. Pluto doesn't seem to have cared, but it's leaving the solar system. Sedna's orbit was already stupid. But at this rate, how long does it take Sedna to orbit? I mean, it's leaving, so it doesn't have it. Time until tidal lock, not a number. Okay. Yes, Sedna's just leaving. Bye! Oh, is the sun about to get eaten by Jupiter? Here comes Saturn out of nowhere. Because technically Jupiter is now bigger than the sun. It still doesn't calculate ignition with proper luminosity though, which is slightly annoying. But we got centrifugal blobbiness introduced into the calculations now. Are we gonna eat the sun this time round? Nope. Kind of surprised actually. Let's... What a thing to say. Let's make it even bigger! Now it is 3 times the sun. Almost 4 times the sun. And my game is like, what are you even doing, bro? Got some interesting flares now. I'm gonna override it, yeah. Looks like a toddler's drawing of spaghetti and meatballs. What is that besides very spicy? Oh. Now it will probably eat the sun. Oh, it's not getting eaten? It's orbiting, but its orbit is like insane. For fragmentable body. I don't know, because food is a good thing. Let's see. Oh! Yeah, it gets within 150 kilometers of Jupiter. That is terrifying. Oh, it went away. Speed it back up again here. Ah. Is this the one that's us acting like a planet? It's such a teeny tiny thing. Yeah. What are you made of? Oh, just silicon. Iron and silicon, yep. As most asteroids do tend to be. Let's... not do anything good. Are you gonna eat the sun? Oh, you're gonna come close though. That was weird. Interesting. The sun's like, nope, skedoodle, bye! Okay. But they are still technically binary. Yeah. Earth is DED, dead. Absolutely GED. Did this one steal my little planet? No. I say mine like I'm Jupiter. That thing cools off and heats up a lot. Iron silicate. Do. Okay, looks like... Oh, here comes the sun. Do. Okay, still not eating the sun. How big does it have to be to eat the sun? We are at 8 times... ish. 7.5 times the size of the sun now. Are you gonna eat the sun? No, but we got rid of that little planet. Here it comes. Too far. Okay. Let's make it even bigger. Really? It's only 10.8 Earth radii? Huh. Somehow it lost some radius, but gained just a F-ton of mass when I've been adding mass. Radius from density, please. No. I guess it's just not a very dense star, it's just really massive. Okay. Let's double the radius. Oh no. What is this happening here? This is panic and death and misery. It's 122 masses of the sun now. Let's save it again, because this is funny. Yes. These little asteroids that are in fact on fire. Okay, sun's coming back. Will it get eaten this time? Stay tuned. Here she comes. Actually, the sun might eat Jupiter, now that I think about it, because the mass of Jupiter is way too big, but the radius of the sun is much bigger. Oh, kablooey. Solar obliteration. And we've got all these little helium clouds. At least they're, I mean, hydrogen clouds, not helium. Okay, it is mostly hydrogen, but with some helium too. I bet I can make a gas giant of these. Yeah, we got 2 little gas giants now. Pardon me. I'm just gonna see what a gas giant C. Gas giant A. Gas giant B. They're small, radius-wise. Okay, that one's bigger than Jupiter. That one's bigger than Jupiter. Are you gonna be a good gas giant? Yes, you are. What about you? Mostly a hydrogen one. We can do that. Okay, we got a few gas giants out of it. Which are about to get eaten by Jupiter, but that's not the point. Cosmic Destruction Boogie! Got an accretion disk forming. But not much else is happening. Curious now. Yeah, Pluto still hasn't got the message. Pluto's just doing his thing. Yeah, it's like there's so many clouds, I'm only going to render at a given frame right here. Okay, what are you? You are not orbiting very far away. Oh, its speed is measured in C now. That's... Woof. Okay. Actually, let's do something hilarious. At least I hope it'll be hilarious. Let's go back to the standard solar system. Yes, I am aware what the solar system is. Thank you, I happen to live there. Then we're gonna take our Jupiter, launch it at really, really fast light speed. Gonna launch it from way out here at light speed. See how this screws with everything. Oh. Uh. Yeah. That didn't... My simulation speed was too fast, and it just never showed me what happened. Okay, let's bring it down to 2 days, or 2 seconds a day or something? Yes, 7 hours a second. This Voyager 1 is now a light day from the sun, so... ish. So we need this to go really slowly, so we can see what in the heck is happening. Okay, 1 hour per second. Let's start way out here outside Sedna's orbit. Because Sedna's orbit is stupid and weird. Light speed Jupiter. Launch. Doot. Okay. So it'll take a few seconds to get in here, but once it does... This is at roughly 1 hour and 20 minutes a second. It's coming. We are blissfully ignorant of the doom that will soon befall us. Okay, let's speed up just a smidge. Our doom approaches somewhere. There it is. As this massive but not very big, it's only about 2 Jupiters across, but 122 times the mass of the sun is approaching. People of Earth look and go, I don't think that should be there. Why is it getting bigger? Oh god. And then it keeps coming and keeps coming, and they realize, oh no, it's headed for the sun. And missed. How did I miss? Okay, fine. That case, it's moving too fast to affect the gravity, but what is happening, these people say. Yeah, that's moving too fast. Huh. Okay. Yeah. Apparently, if it's moving at light speed, which I realized I messed up, because if it's moving at light speed, you're not going to see it coming. It's just going to be there. And then be gone. What happens if I launch it straight at the sun? From straight by the sun. There we go, that's what I expected to happen. Why is the supernova way the heck over there, though? Interesting. We also got lots of little kaboons. Is this the... It looks like the asteroid belt ignited. Earth is freezing over. Oops. Which, I mean... No, it's not freezing over. It's boiling over. What are you illuminated by? There is no more sun. Yeah, it looks like the oceans got vaporized is what happened there. Pluto out here be like, oh yeah. Oh, the Oort cloud lit up too. I guess this thing is giving off enough heat to do that. Oh. Yeah, everything is on fire. Even Sedna is on fire. Eris is on fire. Neptune? It's kind of hard to tell, but I'm pretty sure it's on fire too. Yeah, it's definitely not having a great day. Mars is on fire. Hey look, we melted the Martian ice caps. Go us. We succeeded at melting the Martian ice caps by running a star into the sun at light speed. I don't think that's how you're supposed to do that. Yep, Mars is definitely on fire now. Because of the proximity to this supernova of what used to be the sun. Interesting that it's a Type 2 supernova. It's kind of pretty though. Ooh, it's Air Sprite from Final Fantasy XIV colored. That's what the colors were reminding me of. Okay, let's see how else we can destroy the solar system. Let's try another solar light speed launch, but this time let's do it with a teapot. We definitely don't need this to be going at days per second. Launch a teapot at light speed at the sun and see what happens. It went through the sun. Okay. Let's slow our sim down there to about 3 hours a second. Okay, well, let's launch a light-speed teapot at Mercury then, and see if that does anything, because the sun isn't really substantial in the same way, so... Oh, I launched it at 1 kilometer a second, that's why, not 1 light speed. Jeez. Okay, let's try that again. Launch it at the sun. Although launching at Mercury is objectively funnier, so I think I'll actually still do that. Teapot! Light speed teapot versus Mercury. It went through it. Okay. Maybe 0.99. Nope, it's still going straight through. That's not... Okay, maybe because it's not programmed properly? As funny as it would be to launch at TARDIS. Pumpkin. Near light speed pumpkin versus Mercury. Mercury did not even care. Why is the teapot is way out there now? It's already at 113 AU. Okay. Yeah, it's just going right through. Okay, then. In that case... Yep. Neither the sun nor Mercury care about a light speed teapot. But what happens? Range points. Range points. Where's the replace button? Yes, replace. Let's be silly. 3.83, okay. Replace Mercury with a pumpkin. Yeah! A Mercury-sized pumpkin. I do not know why you would wish to do such a thing. Oh, it doesn't have a rotational period. There we go, we have replaced Mercury with a pumpkin. Auto orbit button, please. Yeah. I do not know why we would want to do that, but that is a very big pumpkin. What can we replace Venus with? How about a D6? Earth, 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 Earth. Venus is weird. 243? Yeah. It does have one. That's right. I don't know why I did that, but I did. Venus is now a D6. Mercury is now a pumpkin. Can I put a... Ooh. Okay. New simulation. Let's try. What happens if we hit Titan? We're not launching at light speed. We're just launching at decent speed. With the moon. But off axis. Oh, that's too close. That's fine. Oh, it makes me so happy to see it go blobby. Because that is how you actually have stuff like that happen. See, now that it's set up to do that... What? Oh, baseball is happening. I'm gonna hit it with something from the top. I'm gonna hit it with an IO from the top. And see how that affects things. I would just ate it. That's cool, though. It's very hot, and you don't want to be there right now. Let's keep wobble warping. What else shall I throw at it? Let's throw Enceladus. Dupe, but at this side. Oh, Enceladus is smaller than I thought. I was thinking of Europa when I did Enceladus. Yeah, I was. There we go. Got lots more outgassing now. Oh, we got quite a bit more water. I think I'm making a planet by smashing moons. I'm also killing my mocap frame rate. This is fine. Let's see if I can hit it with enough stuff to make it turn the other way. Let's hit it with... Iapetus. Which is also smaller than I thought. It's a bigger one, but not as big as Titan. Titan is 0.225, so what's next to 0.225? Well, we definitely don't want measured in scientific notation. That's not gonna help us. Let's hit it with a Callisto. Okay. Let's hit it with a Ganymede. Boop. got it to spin the other way with Ganymede. Yes, let's hit it with a Messier object. That won't be bizarrely sized at all. Let's hit it with some random fictional moons. Doop. Doop. Okay, we're getting closer to Earth-sized. Hit it with a bunch of tiny ones now. Boop, boop, ba-doop, boop, 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 doop. Boop, 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 boop. They're smashing into each other before they hit. Doop. 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 It's almost a sphere now. With lots of mess. It's outgassing like crazy. It's because it's too hot. What's our surface look like now? Surface texture. Oh, our elevation map is an interesting one. Smack it with some more stuff. Boop. 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 Make some more craters here. Okay, now let's hit it with another big one. The actual moon. I mean, our moon, Luna, our friend. Friend moon. Let's see, we're 0.121 Earths. Let's get weird and throw another Titan at it. Okay. Let's throw another Europa. It's what? Oh, Triton. We haven't thrown Triton at it yet. Triton is tiny, so. Let's throw another Triton. Let's throw another Europa, but just to its south end. Let's throw a bunch of random tiny ones again. Cosmic bombardment period, go! Oh yeah. This is where you put Pluto? Fine, I'll throw a Pluto at it. Then I'm gonna throw one each of everything in this category, because reasons. Oh, that's really tiny. Okay, so these are itty bitties. Most of them. We're doing it for the composition and the terraforming. Ceres is one of the larger ones. Pallas. Vesta. Sedna. Almea. Let's tilt up and hit the top with Eris. And Make Make. Bottom side can get... Oh, okay, the orbit is all weird now. Shoemaker leaving 9 is not going to do all that much, but... Apophis, also not really going to do that much. It's got Manly, Neowise. Yeah, let's hit it with a black hole. That'll do anything. Let's hit it with some more moons. Boop, boop. Doop. Doop. I'm glad to see it's eating the mass on the hole instead of just spitting it and outgassing. Okay. Now we take all these. If it's a cloud, it becomes a fragment. Okay. Can I do that with more than one at a time? Yes, okay. Now let's head back to Titan. Or what's left of Titan. Oh, we got something... Oh, we got a few things actively colliding. Let's watch Titan eat it. Titan's having some snacks. Basically, I just sped up the process. My computer's like, what are you doing? There should not be this many things. Oh, that reminds me. Something else I need to bring to the convention. Some cups of chai and some milk, which I'll buy the last day. Like on the way to the convention. There we go. We're still outgassing, but 1 second here, but I got plenty of sugar. One moment. Okay, had to put my watch on the charger. Because this way, instead of buying at the convention center Starbucks, which is nonsense, I can make my own little hot chai lattes. Maybe even iced chai, if the hotel room has an ice machine, which I don't actually know, because I never use the ice machines in hotels. But it's a fancy Hilton, so somebody's got ice. Okay, we got more outgassing, more fragments hitting. Brr. Okay. Can I mass edit their distance? Motion. 946. Okay, fine. Okay. My gosh. Orbital parent. Select object. That would be why it's so slow. There's 946. I don't think I've ever had this many objects before. In Universe Simulator? That's a lot. Now it hung. Go figure. It froze. I broke it. Oops. And now we wait. Okay. Well, it's very frozen now. Okay then. Give it a moment. Yeah, because if I can avoid paying $7 for a convention center chai latte, I will bring my own chai and my own darn milk and use the hotel's coffee machine. Actually, I can get the concentrate and then I don't even have to brew it. That'd be so much easier. So much more expensive though. Still, $7 for a 32-ounce concentrate of chai latte mix, plus maybe $2 in milk, is much cheaper than Starbucks. Okay, how else can we torture the solar system? Let's see. Actually, no. Let's replace Juno, because it's right there, with the Crab Pulsar, because that'll go well for literally nobody. Yeah. It's only a time and a half the mass of the sun, but oh, it just straight up stopped animating. Simulation can't run any faster with current settings than this. Oh dear. Let's let it spin in half a day. That might help my simulation speed. Mega year per second? What the heck? Let's do 1 hour per second. Are we still limited? Oh, it's because it's rendering so many pulsar clouds. That's what the problem is. Okay, then. So, replacing Juno with a Crab Pulsar breaks the simulation. Good to know. Why did my phone try to correct the word second to disco? That doesn't even make sense. Okay. I'm curious. Let's see if it can just run the Crab Pulsar by itself. How big is this actual thing? It's a sun mass. I'm gonna zoom way out so nobody gets flashbanged. Okay. Yeah, I can run in about an hour a second. What happens if we crash the Crab Pulsar into the Crab Pulsar? Will we get a black hole? Will we get misery? Launch velocity at 0.2 the speed of light. Okay. That's closer than I wanted that to be. Distance. Let's do it at a lunar distance. Oh, that's... Oh, the radius is 11.5 kilometers. That radius of the crab pulsar, which has the mass of 1.5 times the sun, is so tiny. Oh, they've just eloped. Okay. Shish. Well, okie dokie then. Halt motion. Maybe I should launch it from like all up in its grill. Okay. Let's see what happens when we do this. Okay. Basically nothing. Okay. Now Kith. Where's the other one? Oh. Oh, they do not want to go together. Okay, let's make neither of them move. Well, now where did it go? Did it just eat the other one? I think it just ate the other one. No? It's way over there. Pulsars don't want to play, man. Hey. Yeah, they're... That's not a speed that can happen in real life. Okay, those are not speeds that you can go? "35 times the speed of light? 70 times the speed of light?" You can't do that. You can't do that in reality. Okay. Okay, let's try something a little different. Let's see what happens if I take the sun, the standard sun. Where is the hecking is my grid? Whoa. Okay, let me start the sim over then. You can't... Even a pulsar can't gravitationally fling... Actually, let's start with the solar system for this experiment. Because this is going to be stupid. Okay, so the sun currently spins at 26 days sun spin. So I'm going to get absurdly stupid with it and have it spin at 26 seconds. seconds. See how that affects anything. Oh. Okay. The sun went flat for a very brief instant, and then immediately ceased to exist. I'm gonna do that again, but with a much, much slower simulation speed. So we can maybe see what happened there. Roughly 30 minutes per second should do. Okay, well that didn't tell us much new. Let's see, how about we set it for half a second per second. Oh, let's slow it down. Oh, there we go. We are flattening the sun. And this is so freaking fast. We're at half a second per second. So this is almost but not quite real time, and thus it has ceased to exist. We exploded the sun by making it go really fast. But if we move this up to around a second for real time, let's start that again, but let's do it at real time. This is gonna go horribly, horribly wrong. Which is half the point of this game, honestly. Okay. Oh. Six seconds. That's funny. Okay, so all it takes is 6 seconds for the sun spinning at a lot of times the speed it normally spins to destroy itself. Okay. Let's see how flat I can get it. Yes, I know what the solar system is. You don't have to give me the pop-up on what the solar system is. I live there. Rotational period. Let's change it to 26 hours. Getting any noticeable wobbly? We are not. Okay. Let's cut this time down. So now I'm going to change it to 26 minutes. We got a disc. It is rapidly losing mass, but wow, it's actually kind of holding itself together at 197 minutes. Flat sun. It's, well, when it comes to solar stuff, let's go even faster. Oh. Yep, that exploded it. Okay, it looks like the limit is about 3 hours rotating before the sun implodes or explodes or flings itself out into non-existence anymore. Yes, I know what the solar system is. Okay, let's see what happens if we mess with Earth's rotation speed. So right now, this is Earth. We live here. I live... Oops. Doop. Zoom out a little more. I live around here. Under that cloud. That axial tilt looks so weird now that you can actually see it that way. Because relative to the sun, I mean, this is winter, but that feels so weird. Okay, anyway, our rotational period is... You are somewhere... Oops. Somewhere here! I one day want to visit... It's somewhere up here. Svalbard. So, our rotational period is weirdly not a day. But okay. Well, that's not really exact, but... Here-ish. In the wizard's face. Because I think the UK looks like a grumpy wizard with a Scotland hat and a whale's ear. Wales is his ear. Let's make Earth spin at 1 hour a day and see how long it takes for everything to die. Oh, okay. We are... What the heck is that? We are losing chunks of planet. Oh, that's true. I always forget about that. Okay. It stabilized at around 2 hours of Earth spin. And naturally it's unrecognizable because everything equatorial got water. You can look at it here. That's so cool. The water moves realistically. And now the only thing I can recognize is up here because, duh. I think that's China. Oh, there I am. That's so cool. Egg Earth. Also, if Egg Earth, water all goes to equator. Which is fascinating. Let's look at our aerial view here. Can I export that? I want to export that. Export surface data. That is so cool. No idea what happened to the moon. Where is the moon? Did we lose the moon? We lost the moon. That's cool though. That all the water decided to nope off to the subtle liquid and keep it going. Yeah, that all the water decided to nope off to the equator. But it stabilized. So interesting though. I guess India is high enough elevation and far enough above the equator that it didn't get eaten too badly. All of Central Africa is gone, but look! Actually, let me turn off the earth shading if I can. Oh, flashlight button. Okay. Look though. We got freaking Super Antarctica, which includes most of South America. Barely Africa. Tasmania made it mostly. Fat Australia. New Zealand's fine. Ooh. The deep Pacific Rim area. Japan is fine but confused. I'm fine. Turn off the clouds. You have a weird square. I guess the Sahara is not desert anymore, although that's south of Sahara, so. Super Arctic. What are you doing to me? Says Earth. The longer it goes, the more the water creeps straight. I'm looking at the depth map here. It appears to also be a bit seasonal. Oh yeah, the Andes are fine. Now they're islands. That's cool. What's the life likelihood here? Did it change at all? Yeah. 56% chance of life. I killed about half of everybody. But we spinning. Like that, I guess. Okay, welcome to New Earth. Everything is very confused. I don't know why they have this stand on it feature. I'm curious now what happens with the other planets. Let's hit up Mercury. Mercury is not going to be happy about this, because it doesn't even have an atmosphere. It's got just a teeny tiny bit of water, but... rotational period. Hour 1. Okay, it seems to stabilize at around 2 hours. That didn't change much because there's nothing to flow around. But the gas pressure sure has changed. It's like, I don't know what I'm doing, boss. Venus. Venus is gonna get real confused really fast. Because Venus is used to spinning around at not very fast at all. Orbital period, 7 months. So 7 months to an hour. Oh, orbital period, not I meant rotational period, not orbital period. I just yeeted Venus into the sun. Okay, let's try that again then. Stop telling me what the solar system is. Rotational period is what I meant to click. 60-minute. Okay. What do we got here? We got some broily gas pressure happening. Oh, that's right. No, clouds are on still. There is no liquid on Venus, apparently. Venus is the egg. That's kind of hypnotic to watch, actually. But I wonder what happens if we do give it water. I mean, it has water, but like an ocean. So let's just change the water to an Earth ocean amount. Okay. Turn off the clouds, maybe? Nope, that did not help with Venus. Okay. Something's going on at the poles there. Okay. Mars time. This time, we'll give it an ocean first. Melt all. Set a liquid. Oh, okay. Well, I guess you want to be frozen. That's fair. 1 day to 1 hour. Planet orbiting sun. Melt all. Flashlight button. And watch as it flings its way to the equator. Yeah. It seems to only want to settle at 1.92 hours, or 1.97 hours. No matter which of the rocky planets I do it at. Olympus Mons is still sticking up. Because of course it is. Although, weirdly, we have a polar circle ocean? It's starting to freeze over, though. Egg Mars. Disk Mars. A second now. Oh, we're getting some freezing. It's taking a while to freeze this big, fat Martian ocean. Talk about insane tidal forces. Okay, now we'll head to the Giants. This could be interesting. Where did you go? Jupiter. Jupiter's already spinning pretty fast. It's already spinning at, what is that, 13 hours? 9 hours. Almost 10 hours. So let's see what happens if we spin it at 1 hour. Flat Jupiter. Oh, it's big enough that it doesn't want to stabilize at that. It stabilizes at about 5 hours. So if it were spinning twice as fast, it would be eggy. I wonder what happens. This is a completely different experiment, but what are we, mostly hydrogen? Yeah, hydrogen. What happens if we replace all the hydrogen with water? Oh, it doesn't let me do that. Okay, fine. With the easy button. Oh, it sprang back into circle. Okay, I guess because it's... Okay. In that case, it looks like the gas giants aren't going to be terribly much fun. But, let's head to Pluto. flat Pluto time. But we want to give it some water. I mean, it has water, but more water. It actually already has a ton of water. Wow, 3 times Earth's water. Oh, that's melted though. Pluto's made of water. Overview. Rotational period, 6.39 days. Oh, okay. 60 minutes. Shoo! Pluto's like, what you doing, man? I didn't sign up for this. We got ice forming. Except at the poles. You do not want to be at the poles. Much as you don't want to be standing anywhere on Pluto at all, ever, unless you're protected, you especially don't want to be standing on Pluto when it's spinning like this. And you definitely don't want to be standing at the poles. Smoosh to the heart. To the point I can't even find it. Pretty sure it's this side though. Yeah. Let's see. Let's do a new one. And see what happens if we take a random main sequence star and launch another main sequence star at the edge of it. Oh, I killed them. That's what happened. It's another cool looking supernova though. I'm gonna save one of these clouds again. Crash bang. Okay. Well, that didn't do what I wanted. Okay, let's, I guess, start with the sun, because it's a fairly stable size. Launch some smaller stars at it. See if that makes it explode. Okay, didn't explode, but he ate it. Wobbly sun. Now I'll launch some planets. Some gas giants. I'll call it Sean, because no particular reason. I'm gonna launch a Jupiter at it now. Did not care. What about a Saturn? It's not gonna care. If Jupiter didn't make it care, it's not gonna care about a Saturn. 51 Pegasus B? That one? No? Okay, Kepler. Kepler's just super Earths. That's fine. Let's launch some random gas giants at it. Oh, we got iron. That's not good. That's not good for a sun. Do it on the beat. It's like Beat Saber, except not. We've got way too much iron in the sun. That is not good. So I'm gonna find another small star. Wish this doesn't tell me the masses on them, but... Because for all I know... Because I don't actually know, that could be a supergiant. Or it could be a red dwarf. I simply do not know off the top of my head. Ooh, do they have... They probably don't. Oh, that's something I could do then. I'm gonna save Sean. There he is. Then I'm gonna do one more real star. Oh no! I'm a fertility tracker now. I hate that. Don't do that to me. Okay. Kind of surprised it's not in here, actually. But... Oh, yeah. Apparently everybody pronounces my name wrong, including myself, because the star's pronounced Myra, and I was named after the star. That's fine. Okay. Let's start with the easy numbers. Huh. Interesting. Approximately 1 solar mass. But it's big. Not meters. We need solar diameters, please. Solar radii, I mean. It's so far away that we can only estimate it. So I'm doing a perfect average of the estimations. He's big. Luminosity is I'm estimating again. Plus equals over 2. Oh. Is bright. Okay, surface temperature. 298. There we go. Age, roughly 6. Don't know why that's important, but it is. I'm my own variable type. Let's see. That is incredibly lightweight. That is insane. Can unlock the radius? No? Okay. Radial velocity. No. What is radial velocity in this case? Oh, that's how fast it moves across the sky. $90 parsecs. I don't have any idea how fast this is because it's 90 parsecs away. Oh, that's for A. Forgot it was a binary. Actually, I think it's a double binary. Okay, and it's moving roughly 100 AU. Okay, are you gonna turn into a planet again? No. Yes, because I forgot to turn a binary. Okay. I have a wave. That's not what Kaufman's list needs to be. Okay, let's see. And technically, the little one is eating the big one. I thought it was a double binary. Interesting. Okay, now I'm gonna save them. Doop. So that I can smash them at stuff. But my phone just told me I need to go to bed, so I'm believing it. Because I should go to bed and eat leftovers, but not in that order.